Okay, I'm going to go through our Performance Final study guide. Probably be 2 videos, but this Performance Final goes back through everything we've done this semester, the highlights. Okay, so things like motion, forces, um, energy, little bit of momentum. Okay, so you're going to see a lot of stuff that we've seen before. Some of it's been a while, so this will be a good refresher. And here's kind of a good summary of all the equations that we're going to use as we go through this. So we have a skateboarder. We're going to be focusing on the activities of this skateboarder as we go through this study guide. So our first question is determine the weight in newtons of a 60 kilogram skateboarder. Remember that weight is your force of gravity. Okay, so that's that force pulling down on you due to gravity from the earth. And when we calculate weight, we always use this equation. Force of gravity equals mass times g. So here we've got a mass of 60 kilograms. For this study guide, we're using 10 for G. We're going to round up from 9.8. Okay, so that'll just make some things simpler. So I've got 60 times 10. That's going to give me 600. And that, again, that's in newtons because that's a force. Okay, that's not your mass by itself. That's the force of gravity on you due to your mass and the acceleration due to gravity. So get 600 there. All right, then we want to draw a free body diagram for the skater when she's standing at rest. Okay, so remember, free body diagrams show all the forces that are acting on an object and the directions that they're acting in. And we usually just draw our object as a box. So the skateboarder over here is this box. And I'm going to draw the ground because she's standing at rest. Okay. So that means she's got her force of gravity pointing downward. She's standing at rest, not moving. So that means there's got to be a force balancing this, and that's going to be our normal force. And that's our force from our surface. So she's standing here on the ground. There's a force of gravity pointing downwards on her, but then this surface is pushing back up on her with the force, and that's the normal force. And those two forces are balanced, so they're going to be equal to each other. And that really helps us with the next question. What is the net force acting on the skater if she's standing at rest? Well, her normal force when she's at rest equals her force of gravity. That means that her forces are balanced. And so her net force, or F net, is going to be 0. You could take this one minus this one. They're the same value, so that's going to give you 0 for the net force. Okay, motion graphs. So the skater is now going to start moving, and she's going to travel at a constant velocity in a positive direction. So we want motion graphs that show constant velocity. First, we've got position versus time. Remember, this is our position of our skater as time is moving along. And if she's moving at a constant velocity, then we're going to have a graph that looks like that. Because our slope, our rise over our run for this position versus time graph, gives us our velocity. So that's change in position as our rise, change in time as our run, and that's the same value at every point if I go along this line. So that means it is a constant velocity. For velocity versus time graph, if it's a constant, then I'm just going to have a flat value. Okay, I'm going to have a flat graph on whatever that constant value is because she's staying at the same velocity value. So as time goes along, blah, 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 her velocity is staying the same. Okay. Okay, imagine she jumped from a plane and dropped straight down. So we want to draw a free body diagram that shows her while she's in free fall with no air resistance. So remember, free fall, we're only under the influence of gravity. So if I'm in free fall, there's only one force acting on me, and that's force of gravity. Again, as long as there's no air resistance. So, and we're not going to consider that here. So the only force acting on her is that force of gravity. That means that she does have a net force acting on her. Her forces are unbalanced. Because we can see that from the diagram. We can see there's only one force here. Okay, that's that force of gravity. And that's going to be the same force of gravity that we already calculated back up here in number 1. Because that's her weight, that's her mass times the acceleration due to gravity. So force of gravity equals 60 for her mass times, again, we're just using 10 here to round up, make it simpler. For our acceleration due to gravity, that gives me 600 newtons. That's the net force acting on her while she's in free fall, because she's only under the influence of gravity. So her force of gravity is pulling her down towards the earth. All right, if the plane she jumped from was 8 meters off the ground, how much time would she fall for? This is an equation where it was like there's a longer version of it we start with, where our vertical height or our displacement is our initial velocity times time plus 1/2 times our acceleration due to gravity, or g, times time squared. She's starting from rest because she's jumping out of a plane, so her initial velocity is 0. So that gives us height equals 1/2 g t squared. And then we took this equation, we solved it for t. So we ended up with one, hopefully you'll remember this from a while back. Time equals 2 times our height over g. And then we take the square root of all of that. That's how we get the time that something's fallen for, okay, or the time that it's in the air if it's an object in free fall. So we want to solve for time. We've got the square root of 2 times our height is 8 meters they gave us. Again, we're going to use 10 just to make it simpler. Let's see. Let me find my calculator really quick. Hang on, sorry. It's in the very bottom of a bag that is full of stuff. Okay. There we go. Calculator. Okay, so I'm going to do the number that is under the square root first, and then I'm going to take the square root just so I don't confuse myself with parentheses. So I've got 2 times 8 is 16. I'm going to divide that by 10. That gives me 1.6. Remember, that's not my final answer. I got to take the square root of that. And that gives me I'm going to round that to 1.3. So she fell for 1.3 seconds, which isn't very long, but she's only 8 meters off the ground, so that's not very high. So, okay, I'm going to do the second page on the next video.